as we look closely at this next piece, we are going to talk about how to reflect a parabola. And what we're looking at is this function, which is correctly graphed over here. If you don't believe these ordered pairs are correct, what you could do is you could look at, well, let's actually write them down. If I were to write out g of x as ordered pairs, it would be 0, 5. We also have the ordered pair 1, 0. Just stick them all right here. Then 2, negative 3. So what I'm saying is if I plug in 2 in for both these x's, squared is 4, minus 12 is negative 8, plus 5 is negative 3. And maybe I'll just give you one more, the 3, negative 4. So the whole thought process is, if g of x is equal to negative f of x, I don't know if that showed up on your page. Oh, whoops. I guess I am getting ahead of myself. That this is the curve for f of x. Sorry about that. So if g of x is negating the y values, because remember this is the negative of y, that's what it means to be f of x. So g of x then would be the same x coordinate, but we have to negate all the y coordinates. Now 0 does not have a negative, so then the other ordered pair would be 2, positive 3, and then 3, positive 4. So let me just change the color real quick. I'm going to do this blue color, 0, negative 5. The x-axis is not going to change, and then 2, 3, and then 3, 4, and then here, here, and here. And they also ask us to come up with an equation to this. I'm just kind of running out of room. But let me put it this way. If we are trying to, if g of x is the negative of f of x, so let me go back up here and just rewrite it as negative of f of x. If I do that on the left side, I also have to do that on the right side. So I have to negate every piece on the right side. And you can confirm some of these things, like the y-intercept being negative 5. So that is the equation, the formula for g of x. And we can explore that on a graphing calculator. So I'm just going to go to y equals, oops, that's still in there. We had x squared minus 6x plus 5. If I go to the next piece, well, let's look at the graph of that. That's exactly like what it looks like on my page. But I could also do the other function and negate everything. And I can see all of my points are flipped over the x-axis. We call this an x-axis reflection. If you're curious, I could even look at the table and show that the y values were all the opposite. So that does confirm it, that we did this correctly. Okay, so I think we're ready. That this is a this is an x-axis reflection. So notice it's an x-axis reflection when we negate, we do the negative of y. So if we look at the next one, the difference is now we have h of x. We can do this in green. And what they did is negate the x coordinate. Well, if I went back to this table of values and negated all of those x values, well, let's go back to those ordered pairs. Well, 0 doesn't have a negative, but 1 does. So it's negative 1, 0. 2 has a negative, so that would be negative 2, negative 3. And then 3 has a negative, so it would be negative 3, negative 4. So if I plot those points, like negative 3, negative 4, -2, -3, -1, 0, and 0, 5 over here. And I just ran out of, I guess I could have kept going, but I would see that the other points would look something like this as well. And the whole point of doing that is so that you can see that this is what we would call a y-axis reflection. A y-axis reflection. And let's think about it. If the x-axis reflection is when we negated y, then the y-axis reflection is because we negate x. Now I'm still not quite done with this because I want to talk about how to come up with the formula. So what I would do is take the f of x formula. So remember, f of x was equal to, I forgot already, x squared minus 6x plus 5. X squared minus 6x plus 5. And if all I'm doing is negating the x's, think about how you're substituting negative x in for the x's. Well, when you square a negative number, you get back to the positive. But if you look at the next thing, a negative times a negative is a positive 6x, and the y-intercept is not changing, which we could confirm by looking at that graph. And they called this h of x. So if I go back to my graphing calculator and type that in, y equals x squared plus 6x plus 5, and look at the graph, you'll see that we did it correctly, which is kind of neat. So here's the rules. If we negate y, because that's what f of x means, it's a x-axis reflection. And if we negate the x value, it's a reflection over the y-axis. So we can use that as a shortcut to be able to come up with linear equations after a reflection in both the x-axis and the y-axis. Now remember, this function is y equals 5x minus 7. Well, if you want an x-axis reflection, you have to negate y. Maybe I'll circle that in blue. Go back to my pink color and just rewrite everything. And if you want to negate, have a y-axis reflection, you negate x. And again, I'm going to go back and write the other stuff in there. So if we want a linear function, we need to solve for y. So just a reminder, maybe I'll switch back to that black color, that we have negative y is equal to negative 5x minus 7. But you need to divide everything by negative 1. So we're looking at y equals 5x plus 7. In other words, and you can name this function whatever you want. Well, you wouldn't want to use g again, so maybe you use like k of x just to have a completely different variable. It would look like this, 5x plus 7. And you could explore with a graphing calculator on why that's correct. So looking at the next one, we have a parabola, looks like this, and we want to reflect over the x-axis. Well, the x-axis is negating the y variable. Well, if we're negating that, then we have to negate all the other pieces. 2x squared, it becomes plus 3x, and minus 8. So negate everything. With an exclamation point, because that's important. So negative 2x squared plus 3x minus 8 looks like it corresponds to option 2. If we look at the next one, we have a y-axis reflection. So what we have to do is negate only the x variable. So let's think about what happens there. So we're just negating each individual x. And when we do that, we get the function, well, negative x when you square it is positive. Negative times a negative is positive. So we're looking at 4x squared plus 7x plus 2, which looks like option 3. Our next one, we have the two transformations that have occurred in order to get this function. So we're going from x squared to this. So I just want you to, and I like to talk about reflections first. So notice what happens is since we negated on the outside, I like to say over. I almost wrote down a cross, but then I don't know what I wrote. This is when we have a negative in front, you know how it goes from an upwards parabola to a downwards parabola? That is kind of like it's reflecting over the x-axis. So you can just think of the problem that way, and then shift. Don't forget about your shifts. We did that before. Up 4. And it's important that you have them in the correct order. And that's why there's more than one correct answer, because maybe you say that we shift up 4 first and then reflect. Well, if you did that, you would have actually shifted down. So this is the important way of doing this. Otherwise, you would have to think of a more complicated thing. But let's keep it simple. And then I think this is our last example. The graph of the function f is shown on 2 grids. Sketch graph A of negative f of x, and then the graph of B is f of negative x. Okay, well, just a reminder, is this negating y, so negative of y, that tells me that we have an x-axis reflection. I don't really like that. I'm writing it over there because I'm going to have to write my answer on this side. So this 0, 2 is going to go below the x-axis, 0, negative 2. 3 units below, it's going to end up 3 units above. Let's see, we have, what's that, 1, 2, 3, 4, 5 above. So it's got to be 1, 2, 3, 4, 5 below. Here, 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 and then also over here. So this graph, and I'm not an artist by any means, but this is what y equals negative f of x is supposed to look like. And sometimes we write it that way. I know that seems confusing, but all you're doing is you're negating all the y values. Whereas if I look at this other one where it says f of negative x, well, I can write it right here. I don't know why I didn't do it over here. When you negate x, it is a y-axis reflection. And what might make more sense is that what's on the y-axis stays on the y-axis. What's 1 unit to the left is going to become 1 unit to the right of the y-axis. 1 unit to the right goes 1 unit to the left. Then we have here, 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 and then all the way down here. And I think this is all that we need to do in this problem. I don't think they expect you to come up with the equations of these, but they're getting you to realize in math we can label things a little bit differently than just equations. So you need to be able to answer questions this way. And you should be ready for the homework.